form a chemical equation. Okay, so how to form a chemical equation? So in the activity number 1, the reaction of quicklime with water. Okay, we'll take that experiment or take that as example. So what we are doing, we are taking quicklime, which is nothing but calcium oxide. Okay, quicklime, which is nothing but calcium oxide, and we are adding water. Okay, we are adding calcium oxide to water. Okay, we are adding calcium oxide and water. If these both react to give calcium hydroxide. Okay, calcium hydroxide. So this is the equation which is written in terms of words. Okay, in terms of words. Now we will see the chemical equation, how to write a chemical equation. So the formula for calcium oxide is CaO. The formula for calcium oxide is CaO, and for water is H2O. Okay, for water is H2O. Okay, now gives rise to, what is the formula for hydrochloric acid? The formula for hydrochloric acid is CaOH taken twice. Okay, CaOH taken twice. Now after writing the reaction, we have to check whether the reaction is balanced or not. See, for this we have to consider, see, there is one atom of calcium in the reactant side. This is the reactant side. Okay, this is the reactant side. These are reacting together to create a product, to form a product. Okay, so now here on the reactant side we have one atom of calcium, and in the right hand side, which is at the product side, we have one atom of calcium. Okay, satisfied. Okay, now go to oxygen. Okay, so we have one molecule of oxygen or one atom of oxygen here and one atom of oxygen here. Totally combined 2 oxygen molecules. Okay, 2 oxygen atoms. Okay, now here see we have 2. Okay, these 2 is for hydrogen and also for the oxygen. So it is satisfied that we have 2 oxygens here also. Now we'll go on to hydrogens. We have 2 hydrogen here and here we have 2 hydrogen here. So we can say that the equation is balanced. Okay, the equation is balanced. So now similarly we'll go on to next example, which is the zinc granules. Zinc granule is reacting with diluted HCl, hydrochloric acid. Okay, diluted. It is nothing but diluted, which is mixed with water. Hydrochloric acid is mixed with water, which we call it as diluted hydrochloric acid. Okay, zinc is reacting with hydrochloric acid and giving us the product as zinc chloride plus hydrogen. Okay, we are getting zinc chloride plus hydrogen. So now this equation is in terms of words. Now we'll write it in terms of the chemical formula. Okay, so Zn plus we have formula for zinc as Zn, and formula for hydrochloric acid is HCl. Okay, hydrochloric acid gives rise to zinc chloride, zinc ZnCl2. Okay, zinc chloride plus hydrogen gas, H2 gas, zinc chloride plus hydrogen gas. Gas can be represented as this. Okay, arrow facing upwards. Arrow facing upwards. So now we have written the chemical formula for this equation. Okay, we have wrote the chemical formula or chemical equation. So now let us just balance the equation. We have one molecule of zinc here and one molecule of zinc. Okay, it is satisfied. Now go to hydrogen. We have one molecule or one atom of hydrogen here, but we have 2 hydrogens here. Okay, so what I have to do, I have to add one molecule of hydrogen here. So sorry, one more hydrogen. So 1 into 2 is 2. 2 hydrogens. Okay, 2 hydrogens. So initially we have 1 hydrogen. If we don't write, if we have 1, if I add 2 into 1 gives rise to 2 hydrogens. Okay, 2 hydrogens. Now chlorine. So we have 1 chlorine here. Now if I add this, we have 2 chlorines. 2 chlorine. Now we have here also 2 chlorines. So which means even this equation equation is a balanced equation. This equation is a balanced equation. So now we'll see how to balance equation in more clear form. Okay. So now we'll learn how to balance an equation. How to balance an equation. So for example, we have hydrogen and oxygen. Okay. Hydrogen and oxygen are combining together to form a water. To form water. Okay. So now if you see here, we have two items of hydrogen and two items or two molecules of oxygen. Okay. In the reactant side. But at the product side, we have only two hydrogens but not two oxygens. So hydrogen, here we have two hydrogens and here we have two hydrogens. Okay, satisfied. Now when it comes to oxygen, we have two oxygens here but we have only one oxygen here. So if I need to balance this equation, I have to add one more oxygen over the reactant product side. But if I add the 2 here, the product will change. The product is changing. My intention is not to change the product, only to balance it. Okay. If I write H2O2, that would be another product. Okay. I am not changing the product, but I am only balancing the product. So what I am doing, I am writing 2 here, so that it is turning the oxygen into 2. 2 oxygens here and 2 oxygens here are satisfied. But I am getting 2 2s are 4. 2 into 2, 4 hydrogen molecules. So now here we have 4 hydrogen molecules. But here we have only 2 hydrogen molecules. So for that, again I have to add 2 over here. So 2 2s are 4. So I have 4 hydrogens here, 4 hydrogens here. 2 oxygens here and 2 oxygen here. Okay. So this is how you add it. Now in similar terms, we'll see one more example. Example number 2. This is nothing but propane. C3H8 is nothing but propane. Propane is generally a colorless gas and odorless gas. Okay. It has no color and it has no smell. Okay. It is used for cooking purposes. Okay. Propane is used for cooking purposes. So if propane is reacting with oxygen, it is giving carbon dioxide plus water. See, we'll see how to balance the equations. Firstly, we'll write all the elements. Okay. See, we have carbon, hydrogen, oxygen here. Okay. In similar way, I have carbon, oxygen. I'll write hydrogen and oxygen. Okay. So now I have 3 carbons here, 3 carbon items here, and I have only 1 carbon item here. I have 8 hydrogens here, and I have only 2 hydrogens over here. And I have 2 oxygen molecules or oxygen items, and I have 2 plus 1, 3 oxygen molecules. This complete equation is unbalanced. This is not a balanced equation. So firstly, we'll move on to carbon, and we have to balance the carbon. So if I have 3 carbons here, if I multiply 3 into 1 gives rise to 3 carbons. Okay. So it is satisfying that we are getting 3 carbons. But 3 is applicable for oxygen also here. So 3 2s are 6. So so the oxygens are turning into 6 oxygens. 6 plus 1, 7 oxygens. Okay. 3 2s are 6 plus 1, 7 oxygens here. Now we'll move on to hydrogens. I have 8 hydrogens here, but I have only 2 hydrogens here. So what I'll do, I'll add 4. 4 2s are 8. 4 2s are 8. So I'm getting satisfied equation that it is 8 and 8 hydrogen molecules. But here we have 3 2s are 6. 6 plus 4. See, 4 into 1 is 4. So we are getting 10 oxygen molecules or oxygen items. I am getting 10 oxygen items. But here I have only two oxygen atoms. So I cannot reduce here. I cannot reduce any atom or molecule here. So what I'll do is on the reactant side, I'll multiply with 5. 5 2s are 10. 5 2s are 10. So I'll remain with 10. So at final check, so we have 3 carbons here and 3 carbons here. Hydrogen, 8 hydrogens here, 8 hydrogens here. 2 4s are 8. And when it comes to oxygen, 5 2s are 10 oxygen molecules, and here 3 2s are 6 plus 4 1s are 4. 6 plus 4 10 oxygen molecules. So now I can say that this equation is perfectly balanced. This equation is perfectly balanced. So this is the example number 3. Here this is iron oxide. Okay, iron oxide is reacting with aluminium. Iron oxide is reacting with aluminium to give iron and aluminium trichloride. Okay, iron chloride is combining with aluminium to give rise to iron plus iron chloride. Sorry, aluminium trichloride. Aluminium trichloride. So now we will see how to balance this equation. See, firstly we have 2 iron atoms. Fe is nothing but ferrous, which is represented instead of iron. Okay, so iron we have 2 molecules, but we have only 1 molecule of iron here. So I'll write the complete equation again. You can write in this way, or you can follow the method which I told you just before this. Okay, so I have to write the complete equation again. Gives rise to, see, and what I am doing, I am adding 2 Fe to balance the iron molecules plus Al2O3. Now we'll see oxygen atoms. Okay, see, I have 3 oxygen atoms, and here also there are 3 oxygen atoms. Okay, it is balanced. Now jump on to aluminium. See, I have aluminium, 1 aluminium here, but I have 2 aluminiums here. So I will write it once again. Fe2O3 plus, see, I have to add 1 more aluminium. So 2 into 1 is 2 aluminiums into, it gives rise to 2Fe plus Al2O3. Okay, Al2O3. So now finally we'll check once again. See, I have 2 ferrous items and 2 ferrous items. 3 oxygen molecules or items, or 3 oxygen molecules or items. So 2 aluminium and 2 aluminium. So now I can say that this equation is balanced. Okay, this equation is balanced. So for this you can say it as step 1 and step 2. Similarly, if you have more number of atoms in the reactants and product size, you will be having step 4, step 5 and so on. Okay, but the method is same. You need to balance in this way. Okay, you need to balance in this way.